Hey everybody, so what we're going to do with this video is we're going to look at our sum and difference identities, and we're going to hit these objectives. We're going to look at our cosine sum and difference identities. We're going to find our cofunction identities, our sine and tangent sum and difference identities. We're going to verify identities, and we're going to use these sum and difference identities to find actual functions of our values. It's going to be a hoot. Let me take a sip of coffee. Alrighty. So when we are doing sum and difference, that just means we are adding and subtracting. What I need you to understand, you cannot distribute into the parentheses. If you're finding the can't distribute into a parentheses with sine, cosine, and tangent. What we're saying is the cosine of a minus b is not the same as the cosine of a minus the cosine of b. You would have to do the a minus b first. Let me show you what we're talking about. Let's say a is pi over 2 and b is 0. So remember, if we remember our unit circle, we're at pi over 2 and we're at 0. So pi over 2 is the 0.01 and 0 is the 0.10. So we're looking at that on our unit circle. So if we do cosine of a minus b as it's written, that's going to be the cosine of pi over 2 minus 1 over 0. Well, the cosine of pi over 2 minus 0 would be the cosine of pi over 2. So when we look at pi over 2, the x value of that point is 0. So the cosine of pi over 2 is 0. However, if we distribute, if we do the cosine of a minus the cosine of b, because I distribute into the parentheses, which I've told you don't do, let's find out why. This is saying the cosine of pi over 2. Cosine of pi over 2 is 0, minus the cosine of 0, which would be 1. That equals negative 1. We're not going to get the same values. This one is wrong. The one on the top is right. This is how we are going to always deal with it. So how do we deal with it? Well, I'm glad you asked. We deal with it because we're going to use our cosine of sum or difference identities. So when we're talking cosine, the cosine of a plus b is going to turn into cosine a times cosine b minus sine a sine b. And the minus ab is going to be a plus. Please notice your signs. So when I'm adding a and b, what I'm going to subtract in the identity, and when I am subtracting inside the parentheses, we are going to add on the other side of our identity. Another way of saying this is instead of trying to remember one or two of these, just remember one. The cosine of a plus or minus b, because you're going to pick whichever one is appropriate, is going to be cosine a times cosine b. The signs change, so we're going to say minus plus. So if I'm using a plus, we're going to use the negative sign. Using a negative, we're going to use the plus sign. And then that's going to give us sine A, sine B. So that's another way of doing it. Well, let's use this information to find some exact values of our cosine and our cosine functions. I was going to say sine, we haven't gotten to sine yet. So let's find the exact value of cosine of 15. Well, if we want to find the cosine of 15, can I turn that into a sum or a difference of two other values? Because I want to try to turn this into either a cosine of a plus or minus b. Now 15, if you remember on our unit circle, is one of those angles that we don't have on our unit circle. The angles we have on our unit circle are 0, 30, 45, 60, and 90. Those are the angles in quadrant 1 of our unit circle. So to find the cosine of 15, that's not one of those numbers. So can we do some adding or subtracting to get a 15? And what I'm thinking, the cosine of 15 can be rewritten as the cosine of 45 minus 30. That lets me know my A value is going to be 45 and my B value is 30. So when we do our cosine function, since I'm doing the cosine of A minus B, the identity I am going to use is cosine A times cosine B. This is a minus, so I'm going to use a plus, not cosine again, sine. This is why we have erasers. Sine A, sine B. So A we said was 45, so I am going to find, goodness, come on. I am going to find the cosine of 45 times the cosine of B, which is 30, plus I'm going to do the sine of 45 times the sine of 30. So in my unit circle, the cosine of 45 is radical 2 over 2. The cosine of 30 is radical 3 over 2. Plus the sine of 45, radical 2 over 2. I'm getting these values from the points on my unit circle. And the sine of 30 is 1/2. So for this first fraction, I am going to get radical 6 over 4 plus radical 2 over 4. Adding these together, they already have the common denominator, so I can have 4 on the bottom. But since the radicals are different, I can't actually add those together. So we're just going to say radical 6 plus radical 2. And then there's nothing else I can do with this fraction. So there is my answer. Boom. Exciting. Let's find another one. Let's do the same thing with pi over 12. This is just like our degrees. Now, if you go back to your unit circle, remember, we know values at 0, pi over 6, pi over 4, pi over 3, and pi over 2. And if you remember in class, I told you we're really cutting the pi over 12 into portions, or our unit circle into 12ths. That means pi over 12 would fall right there. Well, we don't know pi over 12. So if we go back to what we did before, can I do any subtracting to get this to be pi over 12? Well, to get pi over 12, I am going to do the cosine of 7 pi over, I don't want to do 7 pi, 6. So let's see, if we convert these into 12ths, remember we're going to have 2 pi over 12ths, 3 pi over 12, 4 pi over 12. I had to write this down or I was forgetting it. As you saw, I was forgetting it myself. We can't use 7 pi. That doesn't reduce. So which of these values when I subtract will give me pi over 2, or pi over 12, I'm sorry? Well, I am going to use 3 pi over 12 minus 2 pi over 12. So I'm going to do pi over 4. That's 3 pi over 12. Minus pi over 6. And I'm writing them out like this because that's how they appear on the unit circle. These are the values we are going to find. So we know A equals pi over 4 and B equals pi over 6. So when we do our values, since we are subtracting, we're going to say the cosine of A, pi over 4, times the cosine of B, pi over 6. This is a minus, so I'm going to turn it into a plus. The sine of A, pi over 4, times the sine of B, pi over 6. So these are the values I'm going to do. The cosine of pi over 4 on our unit circle, because my first line up, that's going to be the pi over 6. Here's pi over 4. And if you remember our little tricks, the cosine of pi over 4 is radical 2 over 2 times the cosine of pi over 6. Well, that value is radical 3 over 2 plus sine of pi over 4, that's radical 2 over 2 times the sine of pi over 6, which would be 1/2. So again, I am going to get radical 6 over 4 plus radical 2 over 4. And I end up with radical 6 plus radical 2 over 4. And I knew I should have gotten that because pi over 12 is 15 degrees. So we should have gotten the same answer, and I did as the last problem. So let's go ahead and do this one in class. We're going to do the cosine of 87 degrees times cosine of 93 degrees. Let's see if we can do this. So what this is going to turn into is this is saying A is 87 and B is 93, and this is how we find our cosine. So we're going to find the cosine of 87 minus 93. Well, the cosine of 87 minus 93 is, oh, I'm sorry, not a minus. Goodness, that's a plus. That's the cosine of 180 degrees. The cosine of 180 degrees is way out here at -1, 0. So the cosine of 180 degrees is -1. Man, I can't believe I almost messed that up. So pretty cool. And then just a fun fact, if we're looking at the cosine of 90 degrees minus any value, we are saying 90 is A and X is B. Let's do this one when we get together, shall we? Let's leave it as a little surprise. We're going to do this when we get together, and we'll talk about what it means. If you have any questions, please come to class with them, and we'll answer them there. Have a great day, everybody.